Greetings and welcome, friends. Mr. Waddy here. We are on page 191. We were talking about writing equations of parallel lines. Now, parallel lines, we discovered yesterday, are two lines that never intersect each other in the same plane. And we also realized that they have the same slope. So here this question is asking us, there were some others from this set where we actually had graphs and you could use rise over run to find slope. But this question is asking us to find the slope between these points, all right, and figure out if any of these lines are parallel. So in order to do so, I'm going to use the slope formula, which is a great little formula to put in your toolbox, smuggle it into math class in your brain box. This is one that's always going to be helpful. And I'm going to find the slope of each of these lines. So let's see, for the slope of line A, I'm going to do y2, which is 0, minus y1, which is negative 2, over x2, which is 1, minus x1, which is negative 1. And so let's see, so calculating slope, here we go. 0 plus 2 is 2 over 1 plus 1 is 2 is equal to 1 when I reduce. All right, there we go. So there's line A. All right, line A is green. Let's see. Line B will be, I almost called that red, but that is definitely orange. So let's see. For the slope of line B, I'll do y2 minus y1, so negative 2 minus 2, over x2 minus x1, so that's 2 minus 4. Let's simplify. Negative 2 minus 2 becomes more negative. 2 minus 4, signs are different, so I subtract them, and I'll take the sign of the more influential. And negative over negative is positive, and 4 divided by 2 is 2. Okay. All right, yeah, see if you had the same arrangement up top, and if not, then maybe you didn't get the same outcome, or maybe you didn't simplify fully. I'll take a look at yours afterwards as well if you'd like. All right, and then the slope of line C, it's not a bad idea really to label your points. This is M sub B, where I'm saying like the slope of line B was my own name for it. Yeah. So M of C, or the slope of line C, that I was just using my own. Yeah, so this is one thing that I was referring to. So let's see, so y2 minus y1, so 1 minus 2 over negative 1 minus 0. I've got negative 1 over negative 1, and that's just going to equal positive 1. So question, friends, which lines are parallel? Do we have any lines that are parallel lines? Parallel lines have the same slope. Which of these have the same slope? Yeah, so line A, I would say line A and line C are parallel. And we also learned the symbol for parallel yesterday is kind of like these double absolute value bars. It's just like two lines that are parallel to each other. They were really creative with the symbols that day. And the reason those are parallel is because they have the same slope. The same slope. There we go. Wonderful. All right, very good. Let's see here. These problems. All right, this is what we were looking for. All right, let's get ready here. I'm pumped for these. So I've got a line and I've got a point, okay? I'm trying to find the equation that passes through the point that is parallel to that line. Let me actually, maybe I can open up my Desmos grapher here. Let me graph one of those lines here. So y equals 2x plus 2. Y equals 2x plus 2, right there. And plot the point, negative 1, 3. So negativo 1, 3 is like so. Here, it looks like I can zoom in, something like that. Let me actually I'll grab a little screenshot of this guy right there. A beautiful, beautiful. Wow, it was wonderful working with this line. So tell you what. Yeah, I'll do that, I guess. So I'm looking for a line that is parallel to the given line, all right, that passes through that point. So notice if it's going to be parallel to the given line, it's going to have the same slope, and then I would just like shift it over here, and it would have a different y-intercept, right? But it passes through that point. So that's what I'm looking for, essentially. Okay? So my new line, all right, I need, first of all, to take the slope. What is the slope of their line? All right, the slope of line 1. Slope 1 was what? What's the slope of y equals 2x plus 2? Y equals mx plus b. What's the m? What's the slope? It's just the number in front of the x, including its sign. So it's the 2. And so what's the slope of my line going to be? So this one's up 2 over 1, up 2 over 1, or whatever, right? Actually, up 2 over 1 there. There we go. And my line is also going to have a slope of up 2 and over 1. All right? So the slope of our line is also 2. So I've got a fact. Now, to write the equation of my line, hey, I also happen to have a point. So I could call that x1, y1. That's a point on my graph right there. And wait a minute, I've got the slope and the point. The point and the slope. The point and the slope. The point and the slope. Guys, point-slope form. It's just like yelling at us right there. Use me, I can help. And so let's use the point-slope form. I'll write it down in case we forgot it. Y minus y1 equals m parentheses x minus x1. Let's plug this into point-slope form. The facts that I have. Hooray. So I will have y minus 3 equals 2 parentheses x plus 1. Remember, for your points in the point-slope form, they end up being the opposite of the ones we were given, right? So opposite, opposite. It said write the equation of the line. Technically, I'm done. This is the equation of the line, but I know that most of the time we like working with slope-intercept form. I'll convert this to sloppy intercept form for us. I would do so by doing some distributing. Y minus 3 equals 2x plus 2. And to solve for y, what do? How do I get y by itself, friends? Yeah, add 3 both sides. We are becoming expert algebraticians. I love this. I love it. Y equals 2x plus 5 is the equation. Let's so that means it's expecting that my y-intercept was going to be 5 for this graph, right? The b, the slope was 2, the 5 was the b, the y-intercept. Let's just graph this in my little grapher here. Y equals 2x plus 5. Bam! Solid hit. Do you see that? I hit that point. I like 360 no-scoped it. It was amazing. Just poof, right there. Amazing. All right. So that's the general idea for how I would do these problems. If I want the equation of a line that passes through a point parallel to another one, I steal the slope from the first line, and then I plug in the point and the slope either into point-slope form. I theoretically could plug it into slope-intercept form. We've done one of those before back in the day, and solve for b. But either way, you get an equation of the line through a point parallel to the other line. Okay, let's look at question 12 real quick. So here I've got a point, here I've got a line that I want mine parallel to. What is the slope of this line? That's what we would expect, right? But then I realized, wait a minute, what's this 2 doing here? That's not in slope-intercept form. They done tricked us. That's in like no form of, at least no popular form of a line. I've got to convert that to slope-intercept form first. So y equals 3/2 x plus 5 is the other line. Okay, that's not the line I'm looking for. I just need that line so I can figure out what parallel to that line looks like. And what is the slope of that line? Yeah, 3/2. So the slope of their line is 3/2. So what is the slope of every other line parallel to this one going to be? Yeah, I love it, right? It's the same, right? Remember back when I first introduced slope-intercept form, I described slope and y-intercept as being like the DNA of the line. Those are the things that make any line unique. And if I have two lines with a similarity on the outside on their graph, they must also have a genetic similarity in their equation, right? So by DNA, because these ones were similar graphically, they also happen to have the same DNA for, right? Half of their DNA was the same. Their slopes were the same. Okay, so there's my slope. Now let's find, let's see, I've got a point that my line passes through. So let's plug this into point slope form. So y plus 5, right, the opposite of that, equals the slope m, right? So 3/2, parentheses x minus x1, which was 2. All right. So there's point slope form. Let's convert this to sloppy intercept. Pew pew. Distributing y plus. Oh no, the purple. Oh dear. Wrong color. Let's see, 3/2 x, 3/2 times -2. Huh. Well, let's see. I could do 2 times 3 and then divide by 2, or I could do 2 divided by 2 and then times 3. I like dividing first, especially if it goes into it, because division makes numbers smaller, and usually smaller numbers are easier to work with. What is 2 divided by 2? 2 divided by 2? 1, and 1 times 3 is 3. And this one had a minus sign, this one was positive, so it's going to be a negative outcome. All right. All right, solve for y, what do I do? Get out of here, 5. Yeah, get out of here. This is y's side of the equation. Right, y's that jerk. He just like kicked them all out. Let's see. -3 minus 5 becomes more negative. Right there is the equation of a line in slope-intercept form parallel to the given one that passes through this point. Let's just do a quick graph of that, shall we? Let's see. So y equals 3/2 x plus 5. Why? Oh, it doesn't know what plus plus means. I guess I wouldn't either. What is plus plus? I don't know. Actually, I do know what plus plus means. In programming languages, plus plus means +1. So like C++ means take the variable C and add 1 to it. So there you go. But in math speak, no one knows what plus plus means. Let's see. The other one, the point 2, -5. 2, -5. All right, it's not even on my grid. Over 2, down 5. There it is. There it is. So parallel to this, let's see, y equals 3/2 x minus 8. You think we're going to hit it, guys? I hope so. All right, that's parallel. And now hit minus. Bam! Got him! Awesome, friends. Awesome. Wow, we got that. Amazing. Look at that. And yeah, there's the y-intercept of -8. I want to point out, notice that I only used the first line for its slope. I don't care about its y-intercept, right? Like 5 was meaningless to this other equation. I just wanted its slope, and then I found my own y-intercept. Okay, last question. All right, here we go. A Parks and Recreation Department, all right, headed up by Leslie Knope, of all people, is constructing a new bike path. The path will be parallel to the railroad track shown and pass through the parking area at the point 4, 5. So here's parking area, all right, and they're going to draw some sort of path, okay, that's parallel to the railroad tracks. Okay, that makes sense. I got this. So I need to find the equation of a line that passes through this point and is parallel to this line. I'm going to need some slope. So let's first find the slope of the railroad tracks. All right, we'll call this line 1. All right, line 1. Now, I don't have the equation of the railroad tracks. You guys do have the ability to find it, though. You guys are experts at that. How could I find the slope?
You take the points 0, 11, 4.
Mm-hmm.
Then you just do the slope.
Yeah, I'll do slope formula. That's what actually I was leaning towards myself. So I would do y2 minus y1 over x2 minus x1. And so let's see, I'll have 4 over 3, 4/3. So the slope of the railroad with respect to this orientation here is 4/3. What is the slope of the bike path going to be?
You have to do the y minus.
Well, remember, our slope is going to be the same as this slope. All right? We're going to use this in a moment, but our slope is 4/3. Okay? And yeah, we've just got to treat yourself to a bike path is what I'm really trying to do here, right? It's what we should do. This is going to be an amazing park. Treat yourself. And so I know the slope of my line, and I now know a point for this line. So that point we could call x1 and y1. Wow, I chose the exact same color as the grid there. x1, y1. So let's plug it into point slope form. I'll have y minus 5 equals 4/3 x minus 4. All right. So I'm technically done. They didn't ask for it in slope-intercept form, but I don't mind converting it to slope-intercept form, even though I'm going to end up with a fraction answer. That's okay for my y-intercept. Y minus 5 equals 4/3 x. Now 4/3 multiplied by 4. Can I do 4 divided by 3? Not really. So I'm just going to do 4 multiplied by 4. I get 16, and then divide by 3. So I'll have 16/3, and it's going to be negative. And now how do I get y by itself? Yeah, add 5 to both sides. If I'm going to add 5 to this fraction, though, it currently has a denominator of 1. I'm going to have to get a common denominator, so I'm going to multiply by 3 over 3. Right, so I'd get a denominator of 3. You guys, yeah. Some other day we'll do all the adding of the fractions work. But that's going to be the same as y equals 4/3 x. That's the same as 15/3, right? So 15/3 and negative 16/3 is actually negative 1/3. Is what we got. Yeah. So there we go. Now we have the equation for our wonderful bike path. Well, thanks for watching, Internet friends. Have a great day.